apparent frequency of sound wave, heard by a listener, apparent frequency of a sound wave heard by a listener where both the source and listener of sound move towards each other. Apparent frequency of sound wave heard by a listener where both the source of sound and the listener, move towards each other. In the diagram, we have a source of sound and listener. Here, this is the source of sound. S be the source of sound. Here, S is the source of sound which emits sound wave, and sound wave propagates in the medium with the velocity v. Sound wave propagates with a velocity v. This is the direction along which sound wave propagates towards the listener, and v is the velocity of sound with which the sound wave will propagate towards the listener. And here L is the listener. We can assume that the source of sound is moving with the velocity vs. At an angle phi with the direction of propagation of sound wave. This is the extended direction along which sound wave propagates, and the listener, and this is the extended direction of propagation of sound wave in the medium, and the listener L will be moving along this direction with the velocity VL. VL is the velocity with which the listener is moving at an angle theta with the extended direction of sound wave propagation. Also, you can denote the actual frequency. Nu is the actual frequency of sound wave emitted by the source, and nu prime is the apparent frequency of sound wave heard by the listener L. Now we can describe that v is the velocity of sound wave. V is the velocity of sound wave. V is the velocity of sound wave emitted by the source of sound under bracket. S is the source of sound. Nu is the actual frequency of sound wave or true frequency of sound wave emitted by the source. Nu is the actual frequency of sound wave. Vs. Now Vs is the velocity of source of sound. That means Vs is the velocity with which the source of sound S will be moving at an angle phi with the direction of sound wave propagation. At an angle phi with the direction of velocity of sound wave or with the direction of propagation of sound wave. Vs is the velocity of source at an angle phi with the direction of velocity of sound wave or velocity of sound wave propagating towards the listener. We have to consider that sound wave which is propagating towards the listener, and phi is the angle with which Vs acts with the direction of sound wave. Here VL is the velocity of the listener. VL is the velocity of the listener. Velocity of the listener at an angle theta with the extended direction of propagation of sound wave. VL is the velocity of listener at an angle theta with the extended direction of velocity v of a sound wave, extended direction of velocity of sound wave. Here sound wave is propagating towards the listener, and this is the extended direction, and VL makes an angle theta with the extended direction of propagation of sound wave towards the listener. Now we can consider the component of velocity of source of sound Vs in the direction of sound wave. So Vs cos phi is the rectangular component of velocity of source Vs in the direction of sound wave propagation. Similarly, we can consider the component of velocity of the listener, that is the component of VL in the extended direction. So here VL cos theta is the rectangular component of velocity of listener, that is VL in the extended direction of sound wave propagation. VL cos theta is the component of velocity of listener in the extended direction. It should be VL cos theta, not cos phi, and this is the extended direction of sound wave propagation. Sound wave propagates along this direction. This is the direction along which sound wave propagates with the velocity v in the medium towards the listener. Apparent frequency of source of sound heard by listener will be V minus VL cos theta divided by V minus Vs cos phi into nu. Nu prime is the apparent frequency of sound wave heard by the listener in terms of actual frequency nu of the sound wave emitted by the source of sound. Nu prime is equal to V minus VL cos theta divided by V minus Vs cos phi into nu, which is the apparent frequency of sound wave, heard by the listener. And in this case, nu prime has the expression V minus VL cos theta divided by V minus Vs cos phi into nu, which is the apparent frequency of sound wave heard by the listener. But in this case, source of sound and listener both are moving towards each other. If the source S and the listener L both are moving towards each other, the source and listener both are moving towards each other. In that case, phi will be equal to 0 degree and theta will be equal to 180 degree. Again, we can explain the diagram. S is the source of sound and L is the listener. And sound wave emitted by the source of sound will be propagating along this direction with the velocity v. V is the velocity with which sound wave propagates, and the source is moving with the velocity Vs towards the listener. Vs is the velocity with which source is moving towards the listener, and in this case, velocity of source, that is Vs parallel to V, that's why phi is equal to 0 degree. On the other hand, the listener L will be moving with the velocity VL in the opposite direction of velocity of sound wave. VL is the velocity with which listener is moving towards the source. Here VL or velocity of listener is anti-parallel to velocity of sound wave. That's why theta is equal to 180 degree. Nu is the actual frequency and nu prime is the apparent frequency of sound wave heard by the listener. Therefore, nu prime will be equal to V minus VL cos 180 degree divided by V minus Vs cos 0 degree into nu. Nu prime is equal to V minus VL cos 180 degree divided by v minus vs cos 0 degree into nu. Therefore, nu prime will have the expression v plus vl divided by v minus vs into nu, where cos 180 degree is minus 1 and cos 0 degree is 1. And finally, we get nu prime as equal v plus vl divided by v minus vs into nu. Nu prime is the apparent frequency of sound wave provided source and listener both move towards each other. Nu prime is equal to v plus vl divided by v minus vs into nu, which is the apparent frequency of sound wave heard by the listener, provided both the source of sound and listener move towards each other. Nu prime is equal to v plus vl divided by v minus vs into nu, which is the apparent frequency of sound wave heard by the listener L, where both the source of sound, that is S, and the listener of the sound, that is L, move towards each other. Both the source and the listener are moving towards each other, and we get the expression of apparent frequency of sound wave, that is nu prime, which is equal to v plus vl divided by v minus vs into nu. And here both the source and listener are moving towards each other with the velocities vs and vl respectively. In this case, nu prime will be greater than nu. That means apparent frequency of sound wave heard by listener will be greater than the actual frequency nu. Nu prime will be greater than nu. As nu prime equal to v plus vl divided by v minus vs into nu, that's why we can say that nu prime will be greater than nu. Apparent frequency is greater than actual frequency. That means apparent frequency of sound wave is greater than the actual frequency or true frequency of sound wave, provided both the source and listener are moving towards each other. And in this case, apparent frequency of sound will be greater than the actual frequency. Hence, we can say that the frequency of sound wave increases apparently if source and listener move towards each other. Move towards each other. Both are moving towards each other. The frequency of sound increases apparently provided source and listener are both moving towards each other. The following points may be noted. The following points in connection with this fact may be noted from the above equation. The following points may be noted from the above equation. Number one is the apparent frequency. The apparent frequency of sound wave. That is nu, will be greater than the actual frequency if source and listener both are moving towards each other, will be greater than the actual frequency of sound wave. Apparent frequency will be greater than the actual frequency of sound wave. Here nu prime will be greater than nu, as source and listener are moving towards each other with the velocity vs and vl. That's why apparent frequency nu prime will be greater than the actual frequency nu. Number 2, as nu prime is equal to v plus vl divided by v minus vs into actual frequency nu. That's why we can say that we can say that source cannot move with a velocity greater than the velocity of sound wave. But listener can move with a velocity greater than sound wave, because in the numerator we have v plus vl. That's why you can say that the listener L may move with a velocity, the listener L may move with a velocity vl that may be greater than, may move with a velocity vl greater than the velocity of sound wave, that is greater than v. The listener may move with a velocity greater than the velocity of sound. That means VL may be greater than V or less than V. But the velocity of source under bracket Vs, velocity of source under bracket Vs cannot be greater than, the velocity of sound wave, that is cannot be greater than V. Because in the numerator we have V minus Vs. In the numerator we have V minus Vs. Again we can explain that if VL greater than, if VL greater than V, then nu prime will be greater than nu and apparent frequency will be positive. But if Vs greater than V, in that case apparent frequency Vs is greater than V. In this case, as in the numerator we have V minus Vs and Vs greater than V, that's why nu prime will be less than 0. That means apparent frequency will be negative, which is impossible. Nu prime is less than 0, and here apparent frequency of sound wave heard by the listener will be negative. Apparent frequency will be negative, which is impossible. Apparent frequency will be negative, which is impossible. That means if source and listener move towards each other, in that case source cannot move with a velocity greater than the velocity of sound wave. Nu prime is the apparent frequency will be negative, which is not possible. Nu prime less than 0, frequency cannot be negative. That's why we can say that Vs cannot be greater than velocity of sound, that is cannot be greater than V.